On this video, we're going to be learning how to solve systems of linear equations. And so linear means line. So a linear equation is an equation of a line. Okay. So what happens when you have two lines? Well, you can have two lines and they can intersect. And so they intersect at a point. You can have two lines that are parallel and they never intersect. Or you can have an equation of one line, and then you can have an equation of a second line, and even though it looks on the surface like the equations are different, it turns out that they're the same line. So the two equations are actually the same line. And so how many intersection points do we get? Well, all of them. And how many will this be on a line? Well, we'll have infinitely many intersection points. Now, if that's the case, then we have to write a general solution. And we'll see how to do that in examples. Now, there's two ways to solve these types of equation. One is using a method called substitution, and the other is using a method called elimination. So let's look at examples of each of these. So suppose I've got this system. A lot of textbooks will use brackets to show the system. Not every textbook. So suppose I have this system. So I have two equations, two unknowns, and it's a linear equation in that my unknowns, x and y, I don't have x squared or y squared or higher powers, and the x and y's are not mixed. I don't have like an xy term like plus 4xy. Both of these are equations of lines. As you know, equations of lines can take many forms. If we're going to put a line into our graphing calculator, it has to be in the y-intercept form. Y equals mx plus b. But that's not the only way we can have an equation of a line. This is a general form of an equation of a line. If we get it like this, we're going to have to change it to where y is by itself on the left-hand side if we want to put it in our calculator and look at it. But let's just look at this system. So it's a system. There's two linear equations and two unknowns. So what kind of situation are we in here? Okay, do we have we got two lines that intersect? Do we have parallel? Are they the equation of, both of them, the equation of the same line? Well, let's see how we would solve this using the substitution method. Now, it's best used if you can find an equation, one of the equations, and get one of the unknowns, so x or y, by itself. So what I'm going to do is I'm going to number these equations. I'm going to call this equation 1, and I'm going to call this equation 2. And out of these equations, the second equation is going to be the easiest one to get a letter by itself. So I'm going to rewrite number 2, equation 2. I'm going to add 2y to both sides. Well, let me rewrite it. Let me write it down the way it was. Let's add 2y to both sides. So these cancel, and I have this. So now I have an expression for x. And what I'm going to do now is I'm going to take this and substitute it into the equation that I didn't use. And the equation I didn't use was number 1. So I'm going to substitute into equation 1. So equation 1, I'll rewrite it down here, was this. And now I'm going to use what I have in the box and substitute that. So in the box, I'm going to have 4 times x. But according to this box, x is equal to 1 plus 2y. And you got to put that in parentheses because I have more than one term there now. So instead of 4x, I have 4 times that. Then I continue, minus 3y equals 14. Now I've got an equation that only has one letter. I'm going to multiply through the 4. 4 plus 8y minus 3y equals 14. And I'll have 5y there. And then I'm going to subtract 4 from both sides. And then to solve this for y, I'll divide both sides by 5. So I've got y. And now if I put these two boxes together, I have x equals 1 plus 2 times y, but I found that y is 2. X is equal to 1 plus 4. X is equal to 5. So my solution is a point. And remember, points have coordinates x comma y. X coordinate, y coordinate. So these two equations were of two lines that have an intersection point. And their intersection point is 5, 2. Now I can check that in my graphing calculator, but if I do that, I'm going to have to get it into a form where I can put it into my graphing calculator. So here I would have to subtract 4x from both sides and then divide everything by negative 3. That's the first line. If I just want to make sure this is true. And with the second equation, I would have to subtract x from both sides. And then I'd have to divide everything by negative 2. If I want to see these in my calculator and confirm that that's the correct solution. So here I have found the solution. This part, I'm just going to check this in my graphing calculator. So I'm going to press y equals, and I'm going to clear out any old data. I'm going to put that in first. The numerator has to be inside parentheses because it's more than one term. So 14 minus 4x, and I use this button for x, close parentheses, hit the division key, and negative 3. Enter. And then for the second one, I want y equals, and then in the numerator I have 1 minus x. I got to put that in parentheses. Then hit the division key and negative 2, not the subtraction sign, but negative 2. Then do a zoom 6. So here are our two lines, and we predicted that their intersection point would be at 5, 2, and that's exactly is what's going on here. We can see 5, 2. Okay. Now, that was the substitution method. How would we solve the same problem using the elimination method? Well, what I want to do now is I want to look at adding these two equations and getting something to cancel out. But if I add these two equations, nothing's going to cancel out. So I'm going to keep this one the same. So I'm not going to change this one. But what I'm going to do here is if I multiply this entire equation by -4, then the first term would be -4x. And when I add these equations, the x terms will cancel. But I can't just multiply the x by -4. I have to multiply entire equation, so EQ, by -4. Okay, so what happens when I do that? -4 times x is -4x. -4 times -2y is going to be +8y. And then -4 times 1 is going to be -4. Now what I'm going to do is I'm going to add these two equations. And I'm going to keep the equal signs in a vertical column there. So when I have 4x plus -4x, they cancel. When I have -3y plus 8y, I get 5y. When I have 14 plus -4, I get 10. And I get a new equation, 5y equals 10, and I've eliminated one of the variables, x, and I can solve this for y by dividing both sides by 5, and I have y equals 2. Then I can go back and plug in y equals 2 to either one of these equations. It doesn't matter. I choose to use this one because it's the easier one to do it to. So I'll have x minus 2 times y, but y is 2, equals 1. X minus 4 equals 1. Add 4 to both sides now. So x is equal to 5. So my solution is the point 5, 2. Now, a lot of students make a mistake here, and they say that the solution is 2, 5 because they found the y first. And that is wrong. And so the reason why it's wrong, these are coordinates for a point. And y equals 2, that's telling you the y coordinate is 2. And in a point, the x coordinate comes first, the y coordinate comes second. So that's an easy mistake to make. And with multiple choice selections, that's how they can try and trick you. So we got the same answer, which we should. Using substitution method, I got that answer. Using elimination method, I got that answer. Okay, let's look at another example. What about this system? Okay, so let's solve this. What type are we going to get? Are we going to get one of these where we have one solution for a point, one intersection point, parallel, or the two equations are actually the same? Well, if I use substitution, unlike the previous problem, neither one of these equations has it set up to where I can instantly practically get one of the letters by themselves. So I'm going to choose the first equation. And I'm going to try and get the x by itself. So I'm going to add 2y to both sides. So I get this. And now to get x by itself, I'm going to divide both sides by 3, which means I have to divide everything by 3. So that's what I got using the first equation. So now I'm going to substitute it into the equation I didn't use, which was the second equation. So let me write it down here the way it is. And now I'm going to substitute this in for x. So instead of negative 6x, I'm going to have negative 6 times 4 plus 2y all over 3 plus 4y equals 7. Now, the negative 6 and the 3, I have some cancellation there, and when I'm done with that, I'm going to have negative 2 left over. Now I'm going to multiply the negative 2 through. So I'm going to have negative 8, then I'm going to have minus 4y plus 4y equals 7. Now, minus 4y plus 4y, they cancel. And what am I left with? I'm left with negative 8 equals 7. Well, that's not true. Negative 8 doesn't equal positive 7. So what we have here is a contradiction. So I have a false statement. This is a contradiction. And so there is no solution to this. When there's no solution, your book will sometimes use the null set to mean that our solution set is empty. So there is no intersection point. And that's what happens when your two lines are parallel. There aren't any intersection points. Now, what if I'd used elimination? Would I have gotten the same result? Well, if you do everything correct, you should. So the method shouldn't matter. If you do the method correctly, you should get to the same conclusion. So with this one, I'm going to keep that equation the same. So I'm going to do this with elimination method. Now, if I'm going to add these equations, just looking here, if I multiply this by 2, I'll have 6x. And when I add 6x and negative 6x, they'll cancel. But I have to multiply the entire equation by the same thing in order for nothing to change. So I'm going to multiply the entire equation by the number 2. So I'm going to have 6x, and if I multiply that by 2, I'll get minus 4y equals 4 times 2 is 8. Okay. And now what I'm going to do with these two equations is I'm going to add them. So my equal signs have to line up. So I get 6x plus negative 6x, they cancel. And I get negative 4y plus 4y, they also cancel. So on the left-hand side of this equal sign, I have 0 because everything is canceled. But on the right-hand side of the equal signs, when I add, I have 8 plus 7 and I get 15. What we have here is a contradiction. That is not true. 0 is not equal to 15. So there is no solution. And what we have is, in fact, two parallel lines. And now our last example. Let's see if we can solve this system. Okay, if I want to use substitution, and it's up to you to decide which method you want to use, okay, I can see that the second equation is pretty easy to rewrite and get one letter by itself. So what I'm going to do is I'm going to add 4x to both sides. So that will give me y equals 2 plus 4x. I'm going to take this and I'm going to substitute it into the equation I did not use, which was the top equation. So let me rewrite it down here. So I'm going to substitute this in for y. So this equation now becomes 8x minus 2 times y equals negative 4. So I have to expand that. So I'll have minus 4 minus 8x equals negative 4. And then over here I have 8x minus 8x. So what I'm left with is negative 4 equals negative 4. Now, unlike the previous problem, this is true. This is true, but we don't have any way to find out what x or y either one of them are. So when you get to a true statement, but you've eliminated the x's and the y's and you can't get them expressed as numbers, this is telling you you have infinitely many solutions. Now, a lot of students stop right here on a test, and that's not even half the work that's required if you have infinitely many solutions. So if you have infinitely many solutions, then those two equations are actually the same line, and what you have to do is next write a general solution. What do I mean by a general solution? I mean a solution where you only use one letter. And which letter you use doesn't matter. Okay. Now, what are the coordinates of a point? They have an x coordinate and a y coordinate. What did I just find up here? I found an expression for y. So I'm going to replace the y with 2 plus 4x. This is my general solution. You only use one letter. There's only one letter used in this, x. Once you have the general solution, you can find all the points that are on the line. So let's find 3 specific solutions. So this is infinitely many solutions. They can all be written like this. Well, how do you find specific solutions? You're free to let x be whatever you want it to be. Let's let it be something really easy. How about 0? So if x is equal to 0, what point do you get? The x coordinate will be 0. And what will the y coordinate be? It'll be 2 plus 4 times 0. 2 plus 0, which is 2. That is one of the points that would be on the one line that they share. Well, I said to find 3 solutions. Well, how about x equals 1? Then what point do I get? Well, the x coordinate is easy. What will the y coordinate be if x is equal to 1? It'll be 2 plus 4 times 1, which is 2 plus 4, which will be 6. That's another solution. There's infinitely many because you have infinitely many choices for x. How about if x is negative 1? what will my point be that I get? I'll have -1, comma, 2 plus 4 times -1. So 2 minus 4, or -2. Okay, now that's how I did it with substitution. What about elimination? Well, if I use elimination, so let me rewrite these down. This one I'm going to have it stay the same. This one I'm going to change, and just looking there, I'm going to change it by multiplying everything by 2. So multiply the equation by 2. So I'll have -8x plus 2y equals 4. Then I'm going to add. So the equal signs have to be in line. 8x plus -8x, they cancel. -2y plus 2y, they cancel. So over here I have 0. But also over here on the right hand side of the equal sign, I have -4 plus 4. And what has happened? I have a true statement, but it's no help. No help in determining what x or y is going to be. And that means I have infinitely many solutions. So then I must get a general solution, and to get a general solution, I'd actually have to go back and rewrite one of these letters to where I get it by itself on the left-hand side. And in this particular case, it was easiest to get the y by itself over here. And so I'd follow exactly the same steps there. Okay. So these are the easiest types of problems, and I'll be having a list in Blackboard of problems you should be trying in the textbook. These are quite subtle. A lot of students make mistakes on the general and, well, on all of these. When they're using the elimination method, they forget to multiply the number by every single term. And that makes your final answer wrong if you leave it out. And so if you don't get the practice in the textbook, you're going to make that kind of mistake on the test, and that's not going to be good. Okay, so I'll end this lecture here, and I'll have some textbook problems